Well, today, folks, we've got Mark here, and he's been labelling CB radios. As it is the one you particularly would like me to look at. He says, yes, this Team TRX404UK. We did one in 2016, but it could have been the CPT version. This is 2781, so it's a bit more unusual. He tells me it's Cybernet mic, and what does he say? Needs a tune. So he's got the amber sticker on it. We've been through all this before. When he comes over, he has a pile of sets, and he labels them with red stickers if they don't do anything, or if they're doing something, the amber stickers. So we will open it up and we'll see whether there is any innards in it. It's nice and rusty, but it's going to stay that way. And the speaker is connected. It won't be in a moment. That's that done. And what have we got here? So I've got a photo of what the innards should look like, and let's see whether my innards look the same. So I think you have a crystal mixer on these, so you transmit and receive are set separately. I can see we've got, yes, I can see we've got extra crystals there, crystal filters there, a relay. So yeah, good. We'll start writing down some of the things. It's the 16th today. And it's a Team TRX404UK. I'll just make a note it's 2781 because there are CPT ones. And the serial number is 00014 for a copy. Come on. Distributed by Nevada. So let's get it connected up to the test gear, except I haven't got the lead. So you think, why has it got that socket on the side, and why has it got that socket on the front? That's the mic socket, and that's the optional selective calling unit. I've shown those before, and they're in the back catalogue. So we'll get it connected up to power. We'll see whether it does anything. Well, Mark says it does do something, so yeah, there we go. And I understand the Cybernet wired. Just plug our extension speaker in. And there it sits there. Right, so let's have a look at the parameters and transmit 2.1 watts. Channel 40, 2.1 watts. Channel 1, 2.1 watts. That's well balanced. Doesn't have low power. Transmit current 859 milliamps. Let's put picture in picture on, then you can see all this. Is it working today? Well, it wasn't yesterday, even though it showed me it was. I've only just put the test gear on, so we're going to take the frequency with a pinch of salt. But we've got this 2779110, so that's going to be spot on. 2779. I'll put it in, but it will actually go up as the thing warms up. We don't have a VCO method for these radios, but it's working on all 40 channels. and the deviation on this test set, wallow, is 1.4. I'll put that there because it may not be true. Got a dirty volume control, it's coming and going. I'll deal with that immediately if that's possible. Yes, it's got a hole in the side. By the way, it's 7 o'clock in the evening, so we can't do an on the air test today. We'll be out of time on that. So, I can't remember whether we actually have a power control on these. I'll go and look at the circuit diagram I've got on the computer. So we're going to need to set the 10.24 reference oscillator. I know it's not off frequency, but you see on these sets the receive and transmit are separate. So we've got the 10.24 and its adjustment. We've got one of these is receive and one of these is transmit. So we've got a trimmer down there, got a trimmer up there. So I can't remember which way around these are, but that doesn't matter. So we need to get 10.24 right, otherwise the IF of the radio will be off frequency, and then it'll be funny, won't it? And that'll be very funny, peculiar. What's happened to this socket? Yeah, it's loose. So that's going to have to be dealt with. Oh, there's some right spurious emissions. You'll notice, while we have the photos, there are no cores in these. There are no cores. The screen plate's intact, which is great. So I won't do the frequency at this point because I'm going to have to go and look at the circuit diagram, but we'll just go through the transmitter. And the transmitter lineup is going to be there. I doubt it's out. Let's make sure we're on the right meter. Come on, change, that's it. You know what? It isn't spot on. It is. Wow, I didn't expect that. So I've done the second one first, just in case this is not. There we go. Yes, it is. That was spot on. The second one wasn't, but the first one was. Do that one. That was spot on. Can't even see what size it is through there. The bigger one. I was trying to avoid taking the shield plate off, but I might need to see these. I can feel that one. That's in the correct position. But it's always possible this one's broken. No, I can't get into it. I don't think I've come across any team sets I actually like. Just make sure the power's off. Right, so why can't we get this to turn? Let's put the power back on. So we have 3 watts just then. Alright, we'll turn it back off and put the shield plate back on. Power back on. So we've got 3.1 watts at the moment. That may be as far as we go with it, which is better than 2.1. So I'm really going to have to look at the service information. Tell you what though, we can do the receiver, but only if we've got it on frequency. No, I'm going to have to find more information, so we'll come back to this. Right, so I had a look at the circuit diagram for the CPT version between the German language barrier. Can't think what resistor 18 does. I can work out the rest, and first thing I want to do is make sure that our 10.24 is correct. Otherwise, if I set up the transmitter or receiver, I might have the IF out of kilter. So let's see if we can get an earth on something. We'll assume chassis earth at this stage. And it's pin 4 of the synthesizer chip. So I think we'll put this haven't got any probe that's going to go down there, but I'll just clip that onto there and make sure it's insulated. So what I need to do, I probably can probe it on the actual crystal. Yeah, 10.2384. Let's just set that. So as you'd expect it to have done, it's dropped. Of course, it could be the wrong leg I'm on, which it is. Let's try the other leg. .2398. Well, that one doesn't want to adjust, so go back to the one we were first on. 2386. So 2399 is the nearest I can get. 10.2399, monitoring pin 4 of the phase lock loop chip, which is under all this mess. Not ideal. Let's put that crystal back all nice and tidy. So now we can put that away. So I'm just using the oscilloscope as a frequency counter. So now we need to set the transmit crystal, which I understand is this one. You've got the lower one, you've got the upper one. So looking at the circuit, crystal 102 is receive and crystal 101 is transmit. Of course I might be wrong. So let's put the frequency counter on. So it's actually spot on, isn't it? 2779124. But we need to just verify. So between it warming up and me adjusting the 10.24, it's kind of come right. But I just need to verify that we're on the right one. We are. Wow, that's a fine, finicky little control. Wow. So 2779125, we've got that. Now we need to do the same with the receive. So with 2779125 on the signal generator, we can hear that coming through, can't we? It doesn't sound fantastic, but we've got it coming through. We're going to find out whether that's on frequency or off frequency. So I need to get my secondary signal generator. Where's my BNC lead gone? Oh, it's probably the only ones on the oscilloscope. So we want 10.695, which I've got on the yellow channel, if that's what that is. And we need to take the tone off the signal generator. And can you hear that music? I'll just turn the volume up. That musical note is it's off frequency. So if I adjust my signal generator so it is null, we can see that the radio is actually receiving on 27.79.105. So it's slightly off frequency. So we'll go back to 27.79.125. And now adjust the crystal with the appropriate trimmer, which, as I said, is 102. To null, see? So now it's spot on frequency. So that, it has to be done that way round. 10.24, transmit, receive. So you need two signal generators. You can also do it with 455 kilohertz as your secondary one, but it's easier to hear on 10.695. So we now know the radio is master oscillators on frequency, its transmitters on frequency, its receivers is on frequency. So DNTs are the same. Good. So now we can read off, having done that, we can read off what the sensitivity actually is. So let's go over to the synod meter. I didn't do it before because if it was off frequency it was unfair to test it. So I need to plug in the synod meter. Just like that. Put the tone back on. For 12 dB, it's currently doing very respectable 0.47 microvolts. For 10 dB, it's doing 0.41. And for 20, it is 2.3. The squelch, is it another wishy-washy one? It is, isn't it, on these? I don't think we've got a preset. I think we've got a preset for the tone squelch, the selective calling in other words, but that's at full. I'm just making sure it doesn't affect the normal squelch. It doesn't. I didn't think it did. Let's just try again. No, it is for the selective calling. So our full squelch is a measly 1.6 microvolts. So we may be in this trouble that we can't actually squelch out the background noise. It's full. I'll put it in the right box. Now the sensitivity, just check that. It's 0.75. Okay, so now let's go through the receiver and see whether we can improve it. I don't even think there's a detector coil on this circuit arrangement, but we will look. So let's go to the oscilloscope and see if, because I've been making notes, I put T4 in brackets. I felt that if there was a detector, it's that one there. It is the detector, so that is great. Okay, so that's helped a little bit. So we'll go to the synod meter and see what we can get. So about 4 dB, so we're not saturating the receiver, and it should be T1, T2, T3. So T1, T2 and T3 is the IF. That's all there is. Tiny little bit of improvement there. That one was already spot on. So this other one is going to be an IF, so we'll put a bigger signal on. We've got a slight improvement there. So that's that. So we'll get a new reading. I doubt there's much difference. Let's put this over to, well, leave it there. So for 12 dB, we've got 0.46. For 10 dB, we've got 0.39. We're just dancing around. And nearly at 1 there. 1.6. So that's... So the detector being started out has improved the noise. So let's look at the... I'll put the attenuator on the inset picture and we'll see what the S meter says. It should be S9 and the receive meter is the lower one of these two. So it's R30. So I want it to be just 9, like that. But at least they're individual and not fake. So that's that one done. And for transmit, there is no... We've got 3.1 watt. I'll just check. I'm going to put 3.2 because that was when it was hot. Never worry about all this. It makes no difference. 2.9. Channel 1. 3. So it's pretty central. Good. I've got that to tighten up before we can do an on-the-air test. And let's see what the current consumption is now. It's 967 milliamps. No low power, 967 milliamps. And we still want it to read 4, even though it's doing 3.2. So let's just take the signal generator off, go into transmit. It's reading all 4, but we want it to be just all 4. Just like that. So again, remember we're in a commercial test set, so if you put this on a hobby meter, it's probably doing more than 4 watts. But if the government inspector came round, they'll be doing it on a government test, on a commercial test set. So that leaves us with deviation, which looked pretty low on this test set. Let's go back to that screen. Wow, it's 1.5 on here. So I'm going to set that to what we think is correct and verify it on the test set behind me. This might be the maximum we can get. Wow, 2.1 is the maximum I can get on this. So we'll just connect it up to the other test set behind me and see what the quartz lock test set makes of it. So, is the Marconi lying or not? Wow. It says 2.2, so it's not lying today. So it's really as low as you'd want it to be. But that's just how the set is. Certainly not altering component values. So we like it to be 2.2 to 2.5. So it was 1.5 kilohertz, and it's now 2.0 to 2.2 kilohertz. I'd like it a little bit higher, but it isn't going to be doing that. These aren't a set I'd run out and buy, you know. But obviously I did do, otherwise it wouldn't be here. Because we've got a lot of gift sets, and I really appreciate that. It gives us good content on here. But sometimes they're ones which have come in batches that I bought, and I feel sure this is what one of these is. So basically that was correct, and that was correct because it's only got 4 bars. We can't. It doesn't have one of those. Those are all right. We'll be checking the Roger Bleep in a moment. I'll just listen to it over our tannoy system. We've got a receiver on 31, as you should all know. So we'll switch the Roger Bleep on. Beep. Yep, that works. VSQ is for when it has a selective call unit, and it'll be in standby mode till it gets selective calling, which is plugged in through the 5-pin DIN sockets, as I've already discussed. So that leaves us with, what does this do? Is it anything to do with squelch? I hope it is. I've put squelch to full on the radio. What channel am I on? That's better. Just have it's already at full, so I can't really get it wrong. It is a squelch preset, and it was already at full, so that's your wishy-washy squelch. Maximum squelch is 1.6 microvolts. And it's not like there's an RF gain, so this could be worse than a fake Amstrad. Let's look at the sensitivity now we've done that. About 0.7. It's coming and going a bit, but there we go. So if you live in a town, you're never going to get the squelch to activate. So just to recap: transmit meter, receive meter, the two there, transmit meter, receive meter, deviation, which we've got to get on full, it's not quite how we'd want it. That is ordinary squelch, and the final one is tone squelch for the selective calling unit, which you don't touch. So there we are, we're actually done. I need to tighten that up, and I'm Bob's your uncle. So I'm not going to put the lids on, but I'll tell you what we will do: we'll just put it on the aerial so we can finish the video. We'll do an on-the-air test with this tomorrow. I'll just plug it into the extension speaker instead of the instrument speaker. But you do need 2 signal generators, so they're not easy to work on. Made in Korea. I don't know whether that control's dirty. We'll just give it a spray. It's kind of hovering. Yeah, it hovers. 19 Roger. Okay, well, there you are. The Team TRX404UK 2781 edition, and I can assure you there's also a CPT edition, so you've got to make sure it says 2781 there and not CPT across there. It's one to watch, that is. Thanks for watching.